Welcome to the Altai Network Planner tutorial for outdoor deployment scenarios. The Altai Network Planner is a web-based design and simulation tool that helps engineers plan Wi-Fi coverage in various indoor and outdoor environments. It enables you to import maps, add terrain objects, place Altai access points, and predict signal coverage before deployment, saving time, optimizing performance, and minimizing on-site adjustments. In this session, we'll design a wireless network for a container port, a dense industrial environment with numerous metallic obstacles. By following this tutorial, you will learn how to 1. Import and scale an outdoor map. 2. Define custom structures such as container stacks. 3. Place and configure outdoor access points with realistic antenna settings. 4. Run 2.4 GHz and 5 GHz coverage simulations and visualize heat maps. 5. Generate a bill of materials, BOM, and export a simulation report. After watching, you'll be able to use Altai Network Planner to carry out your own outdoor site simulations confidently and efficiently. Use Network Planner effectively to model real outdoor environment. Evaluate signal coverage and identify weak zones. Generate professional simulation reports and materials lists for project documentation. After logging into the Altai Developer Portal, select Network Planner and click Open Network Planner. From the main screen, click Add Project, assign a name such as Outdoor Port Deployment, and describe it as Wireless Coverage Simulation for Container Terminal. Click Confirm. Next, create a new plan for this project. Enable outdoor height simulation, then import your base map. You will then be prompted to choose Dense Space Simulation or Sparse Space Simulation. A dense space refers to indoor environments filled with numerous obstacles that are not explicitly represented on the map. Typical examples include offices, restaurants, auditoriums, low-ceiling spaces. A sparse space refers to indoor or outdoor environments that are spacious and have obstacles explicitly drawn on the map. Typical examples include large warehouses with racks shown on the map or high-ceiling spaces. Outdoor large-area environments are also considered as sparse space environments, such as container yards with container stacks represented on the map, utility plants with metallic structures, and buildings clearly depicted. In this example of container port, choose the sparse space simulation profile for more realistic signal coverage modeling. Once ready, click Set Scale, mark 2 known points, and enter the actual distance, for example 500 meters. Click Confirm to save. Now set the simulation zone, the area in which you'd like to analyze Wi-Fi signal coverage. Drag your cursor to define the rectangular zone and click Confirm. After defining heat map area for simulation, next step is to define objects on the map, which is crucial for realistic signal coverage modeling. In this example, we will specify metallic container stacks, typical obstacles in container port scenario. Before placing access points, we'll model key obstacles, here container stacks. In the Object toolbar, click Add Material, name it Container Stack, and set attenuation to 18 decibels per meter to specify properties of metallic surfaces. Click Confirm to add it to your material list. Now select the container stack material and draw several stack blocks using click and drag or polygon mode. Use set altitude to define their height, typically 15 meters for tall container stacks. Continue until the main storage rows are represented realistically. Accurate object modeling improves the precision of signal simulation in complex environments. Once the environment is defined, we can start placing Altai outdoor access points. Click Edit AP List, add AP, and choose models suitable for large area coverage. For this scenario, we'll demonstrate 3 types of AP. 1. Altai A8NAC. 2. Altai A8EINAC. 3. Altai AX600S. Once the first AP is configured, use duplicate AP to create multiple instances and reposition them around the container yard. Rename them logically. These units help to fill coverage gaps and ensure redundancy around port structures. Next, adjust antenna orientation to optimize coverage zones. Click the 2.4 GHz or 5 GHz tabs to toggle frequency layers. Each AP displays colored antenna orientation indicators. Directional models such as A8NAC and A8EINAC should face traffic lanes and container areas where users or vehicles operate. Fine-tune down tilt and azimuth angles to improve edge coverage. Then click Calculate to generate the 2.4 GHz heat map. Green areas represent strong RSSI values, around -48 dBm, while red indicates weaker signals, below -85 dBm. Repeat the same process for 5 GHz to observe higher frequency propagation range and interference effects. After simulation, click Edit BOM to view all deployed devices. The BOM lists access point models, antenna types, transmit power, and power sources. For outdoor deployments, select appropriate PoE injectors or industrial PoE switches. You can also include Altai Gate controllers such as Altai Gate 210 or Altai Gate 510 for network management integration. Export the BOM in PDF or CSV formats for documentation and procurement purposes. To finalize the project, generate the simulation report. Click Export Project Report to compile a PDF containing device placement diagrams, 2.4 GHz and 5 GHz heat maps, full BOM list. For data backup or later editing, export the project data JSON file or choose Save to Cloud. This concludes our tutorial on outdoor network simulation using Altai Network Planner. We've covered how to import outdoor maps, model real-world obstacles, place access points strategically with correct RF parameters, adjust antenna orientation, simulate coverage, and export professional reports. Use these steps to plan and optimize outdoor Wi-Fi networks efficiently for container ports, industrial parks, and large public areas. Thank you for watching, and we hope this session helps enhance your RF design workflow using Altai Network Planner.